All right. Unit 3, Lesson 2, Investigation 3 is Composite Transformations. The reason why I had you write these rules out is because today we are going to take not just one of these transformations, but two and put them together. Okay? That's what composite means. It means we're combining two transformations. Have you ever heard of like a composite baseball bat or a composite hockey stick? It's a combination of two materials.
Mr. Banks, you're putting too much on one side.
What?
You're putting too much on one side.
It's not me, it's the math department.
Oh.
Okay, can I have their number? You have their number? Miss Corrigan, right next door.
She has it for us.
No, she's the head of the math department.
So she chooses.
No, as a group we choose what's on our tests. All right. Now, guys, this is nothing new. It's just the same thing. We're just going to do it twice now. Instead of just doing one transformation per figure, we're going to apply it twice. Okay. So plot K, H, S, R. Plot it on your paper, please. Okay. Now on your notes, there's two boxes for example 22. Okay. The top one is for A for 22. The bottom one is for B for 22. And the first one down there is for B for 23. Or sorry, the top one is for B. The bottom one is for C. And the next one, the third one is for B, and the next one. Right. So everything I'm gonna write in this graph goes on your top graph. Right. So plot everything I write here. The side has three graphs. Everything I write here goes on the top graph.
Just A.
You plot A, right? And we're gonna do some transformations to A.
So we're using the top two?
Yep.
This one. Okay. So look, we're using these two.
This is the top one. Just the top one.
This one?
Yep, just the top one. I hope that's the most difficult part of this. K, H. Did you plot them already, Andrea? Okay, plot them, please.
Did you? No. Then shut up.
Whoa. Be nice, long. Or to take a long walk down to the office. And I just want to use the joke. It's too long. All right, B. Apply a size dilation of magnitude 2 centered at the origin. What's the rule for a size dilation of magnitude 2?
2S.
XY becomes 2x, 2y. Right? Now on your paper, or on a scrap piece of paper, you might want to write down the coordinates of the image. So if I apply a size dilation to K of magnitude 2, what does my image look like?
0.
0 what?
0, 6.
0, 6, right? What about H? 6, 0. What about S? 0, negative 6. What about R? Negative 6, 0. Okay. So I'm going to plot that. So K prime is 0, 6. That was like a 1. Big prime. Okay. H prime is 6, 0. S prime is 0, negative 6. R prime is negative 6, 0. And then connect these points. So how do we do? Look good? No? We know those sides are all 6 times longer, right? Right? And the area is what times bigger? How many times? Or not 6 times longer, 2 times longer. And we know the area is 4 times, that's 2 squared. Now that was our first transformation, right? It then said, oh, got an extra word in here. Then translate the image. So translate K prime, H prime, S prime, R prime. Translate the image 1 unit right and 1 unit down. So what does that rule look like? XY becomes, I want to go 1 unit right and 1 unit down. So 1 unit right, what do I do? Change X or Y? X. How do I move to the right? Add or subtract from X? Add. So X plus 1 Down, what does that mean? Subtract from y. So now I'm going to take this transformation and apply it to these points. Since I'm applying to these points, these are my second image, aren't they? So I'm going to write K double prime, H double prime, S double prime, R double prime. You guys do the translation? You gotta apply this one, Rebecca. Add 1 to all your x's, subtract 1 from all your y's. That exciting, Josh? Negative 6 plus 1?
Yeah.
Negative 5. Negative 6 minus 1? Negative 7. Okay, so K prime. 0 plus 1 is? 1. That's blue. All right, let's see the blue. 6 minus 1 is?
5.
6 plus 1 is? 0 minus 1 is?
-1.
And we can keep going with this, right? What's S prime? Anybody know? 1 what?
-7.
-7, perfect. R prime? -5, -1. Okay, so now I can plot these, right? K prime is at 1, 5. So 1, 1, 2, 3, 4, 5. It's okay that it's touching the black line. K double prime. H double prime, 7, -1. S double prime, 1, -7. And R double prime, -5, -1. So now I've taken the big triangle and I've slit it. One unit to the right and 1 unit down. Does that make sense? Yeah, does that make sense?
Yeah.
Now, we're looking for what's called the composite transformation. The composite transformation is the transformation that moves K, our original, to K prime, or K double prime, our second image. We want to find the combination that ends up there. The rule that'll take K and move it to K double prime. Any ideas? So what we did, we started with XY, right? We started with XY, correct? Right, guys? What do we do first? We did 2x, 2y, right? Size, dilation, magnitude 2.
Oh, so 2x
Right.
minus m plus 1 and then 2.
What is it, Faith?
2x plus 1 and 2y minus 1.
Perfect. We multiplied by 2, right? Then we added 1 to our x and subtracted 1 from our y. So our combined translation, our composite translation is 2x plus 1, 2y minus 1. Long as I use it, what the heck? Yeah. Does that kind of make sense?
Yeah.
Okay, we'll try another one here in a second. Let's check to make sure. Let's look at K. So I'm going to go from K to K double prime. Right? What's 0 times 2? 0. Plus 1 is? 1. X coordinate works. What's 3 times 2? 6 minus 1 is? 5. Y coordinate works. Must be right. And we could try that with all of them. If we went from the pre-image to the second image, we should get the same answer every single time. Or sorry, we should get the exact number we have here every single time. Does that make sense, guys? Yeah. Okay. Anybody read C yet? It says translate KHSR, 1 unit right and 1 unit down. Then apply a size dilation of magnitude 2 centered at the origin. How does that compare to B? Same thing, but
You're adding opposite.
we're doing 2 steps again, right? I went 2, right? Magnitude 2 size change. Then right 1, down 1, right? So here I'm going right 1, down 1. And then size change. Oh, okay. So you meant not by opposite. You meant the order is backwards, right? We switched the order, right? You guys see that? Between B and C, we switched the order. So we're still using these 2 rules. We're just going to apply them in a different order. Okay? So instead of going here first, then here, we're going to start here and go to that one. Okay? Does that make sense? Now, who thinks we're going to get the exact same final image? Thinks the final image will be exactly the same? Between B and C. Who thinks the final image will be exactly the same? Me, one guy, huh? Who thinks they'll be different?
Okay, are we starting from the green one?
We're starting from the green one, yep. Okay, so starting from the green one, applying 1 unit right, 1 unit up, or sorry, 1 unit right, 1 unit down, and the size change of magnitude 2, will we get the same image as we did in part B when we went in the reverse order?
So we're trying to get the black.
No. We're going to apply the same transformations we did in part B, just in the opposite order. Will we get the same answer? Will our blue square be in the same spot?
No. Yeah.
Who thinks yes, the blue square be in exactly the same spot? Okay, now we have 4, 5, or 4. Who thinks it will not be in the same spot? Okay. So those of you that are saying it will not be in the same spot, you are predicting that the order we translate matters. Okay, that's what you're predicting. All right? All right.
No.
No, we can't change now. We changed enough times. You can change in your head, though. Okay, not going to count again. All right, I'm going to move up a little bit. So the bad thing is we kind of lose our picture. But if we didn't do that, then our picture would be all jumbled anyway. All right, so this was 2x plus 1, 2y minus 1. Oh, I think I might move too far up. I moved too far up. Hang it. All right. There we go. And the third time the charm, right? 2x plus 1, 2y minus 1. All right. So now we're applying the same rules. What happens to our order? They're changed, right? So we're going to do the bottom one first, and then the top one will give me my primes, right? Is it okay if I work within this order, guys? We already did A. That was plotting the green one. Okay, we did B a second ago. Okay, now we're doing C. Okay? And you guys have a lot of space in your notes, so maybe you want to write down the primes and such. Yes, Josh? Sure. Gonna miss some exciting
Are we on the second?
translations. We're on C. Yep, now we're on the second graph, guys. All right. So, still plot KHSR. Okay, so we still have KHSR. Now we're going to do this first. All right. Remember, K was 0, 3, right? K was 0, 3. So I'm going to add 1 to my X, which makes it 1, right? Y, long, pay attention. I'm going to subtract 1 from my Y, which makes it 2. H was 3, 0, right? Right, guys? Add 1 to my X, which makes it 4. Subtract 1 from my Y makes it -1. Okay. S was 0, -3. Add 1 to my X, which makes it 1. Subtract 1 from -3, which makes this negative 4. And r was negative 3, 0. Add 1 to r, you get negative 2. Subtract 1 from 0, you get negative 1. So now we can plot the image. So we do the translation first. We want one right and one down. Does that make sense? Yeah, Justin, does that make sense? Okay. So now we're going to do the size transformation, right? So I'm going to take all these x's and all these y's. I'm going to multiply by what? 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. 2 times negative 1 is negative 2. 2 times 1 is 2. 2 times negative 4 is 2 times 2 negative 2 is. Beat me to the punch that time, Mom. Are these points the same as they were the first time?
Nope.
No. So will we be in the exact same spot? No. So did the order matter?
Yes.
Yes, the order mattered. Okay? So let's plot some points then. Let's just see what it looks like. 2, 4. 1, 2. 1, 2, 3, 4. So this is K. Double prime. 8, negative 2. Okay. Try and give you enough space. 8 will go 1 off here. Negative 2 will go right there. This was H double prime. 2, negative 8. Okay, sorry to go off the page. Negative 4, negative 2. What's your question, Andrea?
Wants to know what the rule is.
What the composite rule is? We'll get there in a second. Now this one is congruent to the other one, meaning the size is the same. It's just in a different spot. So the order did matter. What? It's your notes. It should be an equality that if you turn it in, you get full credit. And yes, if I think you're not using your time wisely, I will make you turn it in. Okay.
It's in here.
It's in there?
Yeah.
Okay, well, it's hard for you to share that with Luis if he needs it. Okay, like if you're sick the next day or whatever. All right. Now we got to find our combined rule, right? Right? So, we started with x comma y, didn't we? Then what did we do first? We added 1 to x. And what did we do with the y? Subtracted 1. Right? Maggie, does that make sense? Jamara, does that make sense?
Yep.
Okay. What did we do next? We multiply by 2. Now, did we just multiply the x times 2? Or did we multiply x plus 1 times 2? We multiplied x plus 1 times 2, right? So I got to multiply both of these by 2. So it becomes 2x plus 2. We had to multiply both of those by 2. Then my y component becomes 2y minus 2. What? You don't get that part. Okay. When we're doing a size transformation, we multiply our x-coordinate by 2, right? So my x-coordinate here was 1, right? The 1 came from 0 plus 1, right? So I'm multiplying the 0 by 2 and the plus 1 by 2. Does that make sense? So I got to multiply the x by 2 and whatever I added it. Okay. So my composite translation that translates from the green one to the blue one is 2x plus 2, comma, 2y plus 2. Yes, minus 2. Thank you. And we can check to make sure. The original k was at 0, 3. 2 times 0 is 0, plus 2 is 2. Right? 3 times 2 is 6, minus 2 is 4. So we are correct. Does that make sense? Guys, does that make sense? Now, besides the picture being different, what else shows me that order matters? Besides the picture being different, what else shows me that order matters?
Coordinate. The rule.
Okay, the coordinates and
Rule.
the rule. Both of them, right? My coordinates of my final image were different, and my rules are different. That tells me the order matters.
So I was right.
Okay? You were right. You weren't here to see why, but you were right. Any questions, guys? Any questions? Would you like to try another one? And the answer here is
No.
no, it's yes. Of course you want to try another one. It's not boring. This is exciting. Well, confusing, I will agree, but the more we try, the less confusing it gets. Yes.
This is so.
Can you get your sweater? We're almost done. All right, so here we have a new, completely new shape. What? Okay. Completely new shape here. What was it now? All right, so we all see our shape here? Okay. So, we first need to plot x, y, z. And we're going to rotate 90 degrees counterclockwise. All right, so x is -7, -2. So that means my drawing is not right. Yeah, we'll fix it. So ignore that green one. Sorry about that. Okay, -7, -2, -7, -2.
Oh, my goodness.
Yeah, that's positive too.
My goodness, Mr. Branch, what are you doing today?
Somebody's got a case for Mondays. Okay, so there's x. Y is at 4, 6. There's y. And z is at 4, -2.
Am I?
Alright. There's x, y, z. Gotta take that green one off there real quick. Oh my goodness. I'm messing it up.
Just the sign.
The sign what? Sign of what, Rock?
To stop.
To stop? No. Can't let the small bump on the road slow us down. We could, but then I feel like I'd be shortchanging you guys. Here. Now y'all got a quick video on how to use Prezi. Alright. One more time. -7, -2. I'll plot this time correctly. X, 4, 6. Y, Z. There we go. Perfect. Alright, are you guys ready? Okay. First thing, we'll rotate X, Y, Z 90 degrees counterclockwise. Then reflect the image of x, y, z across the line y equals x. Right? One rule that maps the pre-image to the final image. So if I'm rotating 90 degrees counterclockwise, that means x, y becomes what?
X negative y.
X negative y. Nope.
Did
Nope.
you say 90 degrees clockwise?
Counterclockwise.
X negative y x.
Negative yx. And then we're going to reflect across the line y equals x. Right? So yx becomes, or sorry, xy becomes yx. Does that make sense, guys? So, let's find our image. So x prime, y prime, z prime. What's x prime going to be? Two, -7, right?
Yeah.
It was -7 too, right? We flip them. The -2 changes sign, right? Y prime, 4, good. Z prime, 2, 4. Nice try. So we can plot that. 2, -7, 1, 2, -7. There's x prime. -6, 4. Y prime, Z prime, 2, 4. We good?
Simple.
Okay. Let's try the last one. XY goes to YX, right? So X double prime means I take these two and do what with them? Switch them. Okay, does that make sense, guys?
Yeah.
Oh, so now on the back.
Yep. Oh no, we're still part C. Or flip back over, Jamar. We're still right there at the bottom of that one. Graph everything on this graph on that one you have right there. Okay. So I took these coordinates and I flipped them, right?
Yep.
Okay. So now I can plot again. So x is at -7, 2. X double prime what? I did. Because we're going from the image, right? Not the original. Okay, not the pre-image. 4, -6. And z is at 4, 2. So, kind of looks like a jumbled mess, right? But can you guys see the black triangle, the green triangle, the blue triangle? You guys see that? Now, I want to write one rule that makes this go to there. Okay.
Huh?
I want to write one rule that makes x go to x double prime. Now, looking at the picture, you might see that rule. Okay?
Yeah.
Well, let's try to go through it and figure it out using composite transformations. Right? So we started with xy, right? Right? We then dig -x or -y x to it, right? Okay. We then flipped. So this was our first step, right? Then we flipped our coordinates, right? So I take these two and do what with it? We flip them. So my composite looks like this. Reflection over which axis?
X.
The x-axis. Okay. So sometimes we'll apply a composite transformation. We'll do two transformations, which really was just one of the other ones. Okay? Because we're just talking about composite transformation. Okay. So these two composite transformations, 90 degrees counterclockwise, then reflecting over y equals x, gives us a reflection over the x-axis. Okay. Does that make sense, guys? Yeah. Okay. For homework tonight, one little thing. One little thing. I want you to try C. That's it. Okay, just try C. Okay, you guys try C. Now you have like 8 minutes left in class right now, so you guys can try C on your own right now.
You want one song